It's time for Maths with Mr. Thomas.
Alrighty then, here we are with chapter 15, Logs and Exponentials. We have made it to the final chapter. Woo! So, we're starting this chapter off looking at surds and indices, and this is a recap of everything you should already know, because before we get into logs and exponentials, you really have to be an expert with surds and indices. So looking at some of the rules that we should already know. Here we are. Anything to the power of 0, if we have a to the power of 0. Sandy, what's anything to the power of 0? Brilliant, it's 1. Good, you need to know that. If you have a to the power of a negative index, a to the power of negative m, Grace, how could you rewrite that so you get a positive index? Excellent, well done. Imagine that as a to the power of negative m over 1. You really want to move the base and the index from the top of the fraction to the bottom, or vice versa. So it would be 1 over a to the power of positive m. If you have the nth root of a to the power of m, well, for that I always think about a little trick, flower power. For this, you're going to have a fractional index, so you're going to have a to the power of m over n or n over m. Which one is it? Well, it's m over n. How do you remember that? Well, if you think about flower power, at the bottom of a flower, what do you have? Good, you've got the roots, which means then that if you look at the root, it's the nth root, and you know the roots are at the bottom, so the n will go at the bottom. This bit here, a to the power of m, well, you can see m is a power, which rhymes with flower. The flower is at the top of your flower, and the m then will go at the top. So think flower power, roots are at the bottom, and then the power rhymes with flower, that's going to be at the top, so you get your fractional index. If you have a to the power of m times a to the power of n, it's the same base. What do you do with the indices, Adam? Good, you add them together, so a to the power of m plus n. When you're dividing, again, it's the same base. What do you do with the indices? What do you do this time? Good, you're going to subtract them, so a to the power of m minus n. And if you have a to the power of m all to the power of n, the quick way of doing that, to work that out, what do you do with the indices, Hannah? Good, you multiply them together, so you'd have a to the power of m times n. Fantastic. Let's try some examples. So example 1, write with positive indices. So here you've got x to the power of negative 2. As Grace says, you can write that with a positive index by moving the base and the index from the top of the fraction to the bottom. Where's the fraction? Well, think about this as a fraction. If you don't have a fraction, then it means it's just going to be over 1. So what you want to do is move the x to the power of negative 2 from the top of the fraction to the bottom. If you do that though, you'd have nothing left at the top, but don't write nothing. Imagine it as 1x to the power of negative 2. So leave 1 in the top, and when you move the x to the negative 2 down to the bottom, it will become x to the power of 2. Woohoo! Next one, you've got 4 over x to the power of negative 3. Again, we're wanting to write it with a positive index. So we've got the base, we've got the index. To rewrite it with a positive index, we move it from the bottom of the fraction up to the top. So doing that then, we'd have the 4, and the x to the power of negative 3 would become x to the power of 3. Woo! That's right. Example 2, write in the form ax to the power of n. So, first one, we've got 1 over x to the power of 5. We want to write it really without fractions. We're just wanting something times x to the power of n. So to do that, again, we have to move the base and the index from the bottom of the fraction up to the top. So if we move the x to the power of 5 up to the top, it'll become x to the power of negative 5. And the 1 we don't really have to write. The 2 over 7x, how could you rewrite that? One common mistake is people would move the 7x up to the top, which is totally wrong. No. All you want to do is you're moving the base and the index. X on its own means x to the power of 1, so you're wanting to move the base and the index from the bottom up to the top. So really with this one, the 2/7 will stay as they are. Leave the 2 on the top and the 7 on the bottom. And the x to the power of 1, when you move it up, it'll become x to the power of negative 1. What this is asking for is rewrite it in the form something times x to the power of something. So really the 2/7, you could just take that out to the side. So you've got the 2/7 times this x to the power of negative 1. It's just another way of rewriting it. With C, we've got the fourth root of x. For this, you may wish to think about your flower power. And for this, you can see the root here. It's the fourth root. And if you think about a flower, what's on the bottom of your flower? Well, you've got the roots. So you know on the bottom, you're going to have a 4. And really, that there is x to the power of 1. That's the power, rhymes with flower. So that is going to be x to the power of 1 over 4. Again, fourth root. That's going to go on the bottom. Power of 1, power goes on the top, just like the flower. Next one, you've got 5 over 9 times the cube root of x squared. First thing for this is probably rewrite this surd. So for this, you've got the third root. Again, think about flower power. On the bottom, you've got the roots. So you know on the bottom of the fraction, that'll become x to the power of something over 3. It's going to be a fractional index. Because it's the power of 2, power rhymes with flower, that's on the top. So you're going to leave the 5 and the 9 and rewrite this as x to the power of 2 over 3. For that, we are wanting it something times x to the power of something. So with this, you could leave the 5 over 9 just as it is. Leave the 5 9s. But we don't want x to be in the bottom of the fraction. We want it on the top. So if we move it to the top, what happens to the index? Excellent. Well done. It goes from x to the power of 2 over 3 to x to the power of negative 2 over 3. And that is going to be in that form. Something times x to the power of something. Something times x to the power of something. Let's try some more. Example 3, simplify 4m to the power of negative 5 times 3m to the power of negative 4. Woo! Let's try this one then. So, Calissa, what would you do first? Brilliant, just multiply the 4 and the 3 together. So 4 times 3 is obviously 12. After that, we've got m to the power of negative 5 times m to the power of negative 4. It's the same base. Calissa, what would you do with indices? You add them. Well done. Good. So you'd have 12 coming from the 3 times 4, and it's m to the power of negative 5 add negative 4. And we all know negative 5 add negative 4 is negative 9. Good. So that would be your answer. You could go on with that and write it as 12 over m to the power of 9, or you could leave it as that. Just look at what the question is asking you for. For this next one, we've got x to the power of 4 thirds divided by 5x to the power of 1 third. So here, if you look at it, you've got a base and an index, base and an index. It's the same base. What do you do with the indices when you are dividing? Excellent. You subtract, so it becomes x to the power of, and then it's the 4 thirds. Take away the 1 third. We're really dividing by this 5, so we're still dividing by 5. Nothing is happening with the 5. From there, x to the power of 4 thirds, take away 1 third. What's 4 thirds take away 1 third? Well, that's just 3 thirds. Again, we're still dividing by 5. And 3 thirds is the same as what? Good, it's just the same as 1 whole. So it becomes x to the power of 1, which is just x. And again, we're still dividing by 5. Nothing's happening with that. Next one, we've got 3 over root x, take away 2 times x plus root x. Sammy, do you remember how to work this one out? Yeah, multiply the brackets. And to do that, take this first term and multiply it by the first term. For that, because you're multiplying the fraction by just x, you could always imagine x is x over 1, turn it into a fraction, and then multiply the numerators, multiply the denominators. If you do that, 3 times x gives you 3x, and the root x times 1 will give you root x. After that, you're wanting to multiply again, so you've got the 3 over root x times root x. Again, you could always think about the root x as root x over 1. So multiply these two fractions together. 3 times root x will give you 3 root x, and root x times 1 will give you root x. After that, you're wanting to take the 2, so negative 2 times x will give you negative 2x, and the negative 2 times root x will give you negative 2 root x. Hopefully those last two are dead easy. From there, you've got 3x over root x. Well, you could do this a couple of different ways. X you could rewrite as root x times root x. And then if you cancel a root x from the top and 1 from the bottom, you'd have 3 root x. Or you could think about root x as x to the power of 1/2. So really, you've got x to the power of 1 divided by x to the power of 1/2. Same base, subtract the indices. So it'll leave you with 3x to the power of 1/2, which again is root x. With the next one, well, you've got root x in the top, you're multiplying by it, you're also dividing by it on the bottom, so they'll cancel, leaving you with 3. You've still got the minus 2x, can't do anything with that, and we've still got the minus 2 root x, can't do anything with that. From there, gather your like terms. So we've got root x's. How many root x's do we have? Well, we've got 3, and then we're taking 2 away. 3 take away 2 is 1, so we're left with 1 root x. We still have that plus 3. There's no other numbers just on their own to add or subtract. And number of x's, we've got the minus 2 root x. So that will be its simplified fully. Example 4, rewrite as surds. So this time we are wanting to bring in roots. So with m to the power of 5 over 3, really this time we're just wanting to go back the way. So again, think about flower power. In the bottom of a flower, you've got the root. So here at the bottom is a 3, so that's going to be the root. So you know it's going to be the third root. And because you've got m to the power of 5, the power is on the top, it will be an m to the power of 5. I always prefer writing it as the third root of m, put all that in brackets, and then put the power of 5 just outside. You could also put the 5 in here as well, so it's m to the power of 5, and then the third root of that. Either way, it's going to be the third root. With the next one, you've got x to the power of negative 3 over 4. What would you do with this one? Valley, we've got a negative index, which is difficult to work out. Mamma mia. So what would you do? Good, rewrite it with a positive index. So that will then become 1 over x to the power of 3 over 4. With the 1 in the top, just leave it there. But x to the power of 3 over 4, Valley, what would that become? Brilliant, well done. It's going to be the fourth root. So you'd have the fourth root of, and then x cubed. Or, as I said, you could take the fourth root of x, put brackets around that, and then put the power just outside. Next one, you've got 2 over p to the power of negative 7 over 2. Again, we've got this issue with the negative index. Olivia, help us out. What do you do? Yeah, move the base and the index to the top. So keep the 2 just as it is, and then move the p to the power of negative 7 over 2 up to the top. And that magically changes the index from a negative to a positive. Woo. From there, well, the 2 is going to stay just as it is, but p to the power of 7 over 2. Olivia, finish this one off. What would you do? Good. On the bottom, you've got the root. The 2 is the second root. In other words, just the square root. So it'll be the square root of, and then you'd have p to the power of 7. Or, again, you could put brackets around the root and do that to the power of 7. And that will be your answer. Example 5, evaluate without a calculator. Muzamil, bad news for you. Here we go. So example 5a, 2 to the power of negative 4. Working this out. Muzamil, let's stick with you then. I know you can do it. What would you have? Brilliant. Rewrite this with a positive index. If you have to work out 2 to the power of 2, dead easy. 2 to the power of 3, dead easy. 2 to the power of 4, dead easy. 2 to the power of 5, 2 times 2 times 2 times 2 times 2, dead easy. When it's a negative index, so it's difficult to work out. What on earth does that mean when it's working out to the power of negative 4? No idea. So you rewrite it with a positive index. This then will move to the bottom of your fraction. So treat that as 2 to the power of negative 4 over 1. Move the base and the index to the bottom. Remember, you'd be left with 1 in the top, not 0. And the negative 4 will then become a positive 4. Well done, Muzamil. Finish this off then. 2 to the power of 4 is... Good, it's 2 times 2 times 2 times 2, which will give you 16. So we'd have 1 over 16. Well done, Muzamil. You could do it. Next one, you've got 16 to the power of 5 over 4. Working this out again without a calculator. Well, on the bottom, you've got the fourth root. So, think flower power, it's the root, so you'd have the fourth root of 16. Put brackets around that, and then at the top, think flower power. In the top, you've got the flower, which rhymes with power, so that will go to the power of 5. From there, the fourth root of 16. Leah, what's the fourth root of 16? Good, it's just 2, because 2 times 2 times 2 times 2 will give you 16. So the fourth root of 16 is 2. We've still to multiply that to the power of 5. So 2 to the power of 5 is... Good, just 32. Well done. And for C, with this one, it's looking a bit trickier. We've got 2 to the power of 3 over 2 over 27 to the power of negative 2 over 3. So with this one, what would you do? First of all, help us out, Mary Lou. Good. The 27 to the power of negative 2/3. Well, again, you've got this negative index, which is difficult to work out. So you want to rewrite this with a positive index. How do you do it, Mary Lou? Good, you can just move that from the bottom of the fraction up to the top. So leave the 4 to the power of 3 over 2 just as it is and move the 27 to the power of negative 2/3 up to the top, and when you do that the negative will become a positive. And after that we can then work out each part. So 4 to the power of 3 over 2, think flower power, on the bottom of the fraction. Well, on the bottom you've got the root, think flower power, at the bottom of a flower you've got the root, so it'll be the square root, the second root of 4, and that'll be to the power of 3. With 27 to the power of 2/3, again in the bottom of a flower you've got the roots, so it's going to be the third root, or the cube root of 27, put brackets around that, and we know the power is 2, so we're then squaring that. The square root of 4 is 2, so we've got 2 cubed. The cube root of 27, what number times itself 3 times gives you 27? Well, that's 3. We've still to square that. After that, it gives us 2 to the power of 3 times 3 to the power of 2. Well, for that, 2 to the power of 3, we know that's 8. 2, 3 squared is 9, and multiply them together, and we get 72. Ooh. Example 6, solve for n. So a couple more examples here, similar to the textbook, just checking your understanding of this. But 2 to the power of something gives you 512. To work this out, really what you're doing is you're thinking, right, well 2 to the power of 1 is 2, 2 to the power of 2, 2 times 2 is 4, 2 to the power of 3 is 8. You can start working your way up, so you'll get up to 2 to the power of 5. 2 to the power of 6, multiply that by 2 again, multiply it by 2 again, so it's 2 to the power of 7, 2 to the power of 8, 2 to the power of 9 gives you 512. So you know then 2 to the power of 9 is 512. So you know n must equal 9. Well, the next one, larger numbers here, 7 to the power of n. Again, you know 7 to the power of 1 is 7, 7 to the power of 2, 7 times 7 is 49. You can work out 7 to the power of 3, 7 times 7 times 7, 7 to the power of 4. So multiply by 7 again, multiply it by 7 again, multiply it by 7 again, and look, we've got this answer here. So you know then that n is going to be 6, because it's 7 to the power of 6 that will give us this number. Example 7, solve for n to 2 significant figures. So 2 to the power of n equals 10. That's what we've got. We're wanting to work out this value of n. Something that we should already know. Well, if you do 2 times 2, you get 4, times that by 2, you get 8. So in other words, 2 to the power of 3 is 8. If you multiply that by 2 again, so 2 to the power of 4, well, that's 16. So we know for this, it's not going to be a whole number. We're going to have something that's between 3 and 4. Really, what you should be doing is using logs to solve this problem. However, we've not learned about logs yet. If you are one of the people that has already learned about logs and you're back just reviewing this lesson, then obviously you can go back and use logs to solve this. But if you haven't learned about logs, here's how you would do it. So you know the number is going to be somewhere between 3 and 4. So what you want to work out, using a calculator, is 2 to the power of 3 point something. Let's just pick something random. Well, 10 is closer to 8, so we know the number is probably closer to 3 than it is 4. So let's work out 2 to the power of 3.2. Working that out on your calculator, type that in, 2 to the power of 3.2. That gives us 9.19. After that, well, let's try 2 to the power of 3.3. Maybe that's even closer to 10. So work that out. 2 to the power of 3.3. Working that out, that gives us 9.85. Okay, that's pretty close to 10. Let's see if we can get any closer. So let's work out 2 to the power of 3.4. Use your calculator, work out 2 to the power of 3.4. That gives us 10.55. Well, wait a minute, we've just gone over 10. What we're looking for is what number here for n will give us 10, just to 2 significant figures. But for this, 2 to the power of 3.3 is going to be close to 10. 2 to the power of 3.4, that's also close to 10. So really, if we keep going up with 2 to the power of 3.5, that's going to be even more. So we know then it's going to be somewhere between 3.3 and 3.4 for your index. However, because 2 to the power of 3.3 is closer to 10 than to 2 significant figures, the value of n that we're looking for is 3.3. That's really how you would work that out, or start working it out without using logs, but really you should be using logs to solve this if you have learned about them already. Let's do one more example. Example 8, find the smallest value of n where n is an integer, such that 4 to the power of n is bigger than 10,000. So start working this out then. Again, we're looking for an integer, so we're looking for 4 to the power of 2, or 4 to the power of 3, 5, 7, 9. We're looking for 4 to the power of something. So 4 to the power of 1 is 4, 4 to the power of 2, 16, 4 to the power of 3, 64. Start working your way up. 4 to the power of 5 will give us 1024. Multiply by 4 again, so 4 to the power of 6 is 4096. Again, that's less than 10,000. We're looking for an integer where that'll give us a number bigger than 10,000. Work out 4 to the power of 7. 4 to the power of 7 is 16,384. Well, whoa, that is bigger than 10,000. That then is what we're looking for. We're looking for the smallest integer, for which when did we do 4 to the power of that will give us something over 10,000. So the smallest number then will be 7. So n equals 7 will be the number that will give us something over 10,000. Anything less than that will give us less than 10,000. Try some of these questions. Just make sure you are an expert with surds and indices. There are questions in the TJ Higher Book, page 161, exercise 17.1, and there's also ones in the Heinemann Higher Book, page 289, exercise 15a. Give them a shot. Any problems? Let me know. Have fun.